for Fourier series transform, basically that's the formula here. So as long as right now in these sections we focus on periodic functions, so as long as the force excitation is periodic, and if you can identify the period t, then you simply plug into this formula and just do hard work. Okay, just do the hard work, and then it will be also common if you look into internet and look into Fourier series table, okay, that kind of certain keyword, and very likely you will find the table and to match the common periodic functions, and that table will give you the result, that means a calculation for coefficients. For that regard, and here I summarize a few common signals and the periodic force functions. For example, here is the pulse-wise in 50% PWM, the square form. So that is the one here. And this is the one I use to assign in homework 9 and homework 10. Okay, so again, the goal of the practice is not to have everyone to redo Fourier series transform calculation. No, that is not our goal. Our goal is to, with the information, is how do you calculate the response of the systems. Okay. So in this way, if you have started the homework 9 and you see what I'm saying here. And this is a triangular, so in a similar way we have this, and also we have this kind of the ramp, periodic ramp, and something like this one here, okay? And this is another type. So here is what I've seen. Here I want to make a comment, and for example, let me take up the homework-related question like this. Okay. So what I want to say is, if you would know the base form, something like this, and based upon the base form, you can do some linear algebra and to get a similar the Fourier series expansion for the similar one. And so that is the part of the problems in homework 10. But here, let me demonstrate for one thing here. So for example, here, let me redraw the response. Sorry, redraw the forcing functions. So the forcing functions right now given for that one simply is between, this is ft, and between -1 to 1. And that period is 2 pi. Okay, so here I simply plot, only plot the functions in one period, and this basically is repeated from that end to this end. Okay, so here we are given the Fourier series expansions. So if on the other side, if you have any chance, you know your functions will be similar to this shape, but different period, or they have a shifting. So let me make one example here. So one example is this one. Let me use the color. So for example, if your function is from -0.5 to 0.5 and the same period. So basically this is a half of the magnitude in the signal. So with this information from the table available, then how can you determine the Fourier series expansion for this curve? It's simply because the magnitude is half. And if you look at the Fourier series expansion, that is a linear combination of the harmonic terms. So you simply all the coefficient divided by 2, and that is for this one. You good? Okay, so if magnitude scaling say to any number of n, you simply scale this expansion, this kind of expression by the same the number of n. Scale, that means multiply. Okay. So these are the first questions. The first one. The second one. If you have, let me call this is F1T, this is F2T. If you have another similar pulse-wise, however, that is something like this. It's not oscillated. It's not oscillating respect to 0. However, it's oscillating respect to, say, let me say any number, say A naught. Not using different numbers, using alpha. Okay. And that one is like this. So, for example, from here to here, this is say alpha plus n, and this one is alpha minus n. Okay, and for this case, this is the same period, pi to pi. Okay, so basically this is with the same period, but simply have shifting in the magnitude, also have a scaling. So for this case, it has a shift in magnitude by alpha, and it has a scaling by magnitude of n. So for this case, because you shift it, again, that is, you can imagine for this signal everywhere compared to this signal, everywhere have two steps of the operation. One is you simply magnify the magnitude by the ratio of n. That's the first thing. So pertaining to our formula here, so you simply multiply the whole series with n, and that's about the scaling. In addition to that one, you can see everywhere in this signal, it has a magnitude is alpha plus a constant alpha to the original one, because this oscillating is about this level alpha. So that is a linear, again, this is a linear combination of every single harmonic term. Constant simply is corresponding to frequency 0. So in this case, you simply plus alpha. You got okay? Okay, so this is the essence I ask you to give a practice in homework 10. And if you get this concept right, then basically you can manipulate the fundamental essential tables and to do whatever you like. Okay. The final one, and that one is we have a frequency change. So let me redraw this one. So if we have another functions, and for these functions, for example, here we have, right now the period of this function is double. So let me say this is 2 pi, this is 4 pi. Okay, so the same time t. So for these demonstrations, and this is 1, this is minus 1. So here I only focus on the scaling in the time domain. Okay, so basically for this case we have such information. So and so for our exercise, this x corresponding to, in terms of our dynamics, should be time. Okay, so let me swap. So maybe in this way, if you like, you can swap the independent parameter into time domain. Okay. So for this case, how can you manipulate the information and using this information to manipulate the template to get the result? Any suggestions? Yes.
Couldn't you have the input variable?
Yes. So usually is they have the input variable. And any other good way? The usually in mathematics, it's more systematic is this. You simply say in this time, you say in this the new time scale is simply using different scales, say T1. Okay. So T1 in this way, you try to, because they have the same patterns. if you scale T1 by T1 divided by 2, then basically the information like this, if this is become T1 divided by 2, then information of this one simply is become like this. This is pi, this is 2 pi, right? So that means I try to manipulate information. If imagine if we have the time scale by then we would have information. So that means under this situation, this is equal to this one. So that means compared to this, we know that is in relations, get the same pattern, we know how we have this information. So under these situations, you simply plug in is this using this template, and you simply replace T by what is the relation T1 over 2. So basically that's what you're saying, we scale the things. Okay, so in this case, and if we don't have any scaling, that means pi over 4 and sine T by T2, so that is T1 divided by 2 and 1 plus 3 sine 3 T1 divided by 2 plus something. Okay, so once you manipulate the whole thing, is basically this is the expressions of the Fourier series expansion in the time domain, and that is symbolized by T1. So once you have the new expression, you simply, if you like, you can get rid of the bothersome one, then you get the general expressions. Okay, so I think this is more important for our engineering application. Know how to use tabulated result. And so with this kind of information already, I believe our focus, and again, my focus will be help you to practice the system response to the signal, not mathematics. So that means in terms of the homework, in terms of tests, I will provide you the basic information. Okay, and that is your job to manipulate from the basic information to what we need, what you need, and then plug into the information we learned and just do it. Okay, so give a try. I believe with this information in place, you should be able to complete homework 9 and homework 10. And the original is in one single set, and so I split into 2. In this one, I will give you more points, because if in the single original integral set and there's so many questions only worth 100 points, I don't think that's fair to everyone. So I split it into 2 portions. Okay. So that is the first portion here. And any questions about anything?